All right, so I posted some background information. I don't have time to go into all the background information necessary, but there it is. A perpetuity costs 77.1 and makes end of the year payments. A perpetuity pays 1 at the end of year 2, 2 at the end of year 3, at the end of year n plus 1. After year n plus 1, the payments remain constant at n. The annual effective interest rate is 10.5%. Calculate n. Okay, so let's see what's going on here. You pay 1 right here, right? And then 2, and then 3. And then it says we go to n right here, right? And of course, this would be the pattern, right? Okay, great. And then after that, I'm just going to do it above so we can differentiate it. Payments stay constant at n, okay? Right? And this one's the one that goes on forever. So the arithmetic one stops, but the one that's just n goes on forever. Okay, and calculate n with the given interest rate of 10.5%. Okay, great. Now, notice how we can kind of group it into an arithmetic one right here. Arithmetic annuity, right? So let's deal with that first, okay? I should have put that in orange. So that's going to be, oh, and by the way, this is, it says it costs 77.1, so this goes right here. Now, if I want to accumulate it to this time period, I'm going to multiply by 1 point. I'm going to take 77 and multiply by 1.105 because that's going to be more useful that time period. So 77 times 1 point, also known as my comparison date. So I get 85.085. Okay, so that's the one I want to use. That's more important. Great. So I'm going to use my P and Q formula because I have 1 A angle N, right? I'm dealing with this right here. So I have 1 A angle N, and my increase is also 1. That's my Q. A angle N minus NV to the N all over I. I'm not substituting any variables in yet, right? So now what I've done is I've discounted all of the highlighted stuff back to here, which is good. And now I got to deal with the purple, okay? So the formula is just X over I, where X is the payment. In this case, it's N, okay? So I'm going to say plus N over I. But that just takes all of these. All that does is take it back to this time period right here. And what's the comparison date? It's right here. So I need to go back to here, okay? I need to go back to there. Another easy way to think about it is if I were at n, I would discount it n periods to get to 0, but I'm at n plus 1, so I need to discount it n periods. So it's going to be v to the n. And that's going to be equal to not 77.1, but 85.085. Great. We're going to see some stuff is going to cancel. So I have A angle N plus A angle N upon I minus NV to the N upon I plus NV to the N upon I equals 85.085. So we can say that this cancels out. And now I'm left with A angle N plus A angle N over I equals 85.085. Okay, so I'm going to make it I over I So then I get A angle N 1 plus I upon I equals 85.085. Okay, now what we can do here is 1 plus I upon I we can figure out because I is given to us, right? 0.105. So substituting that in, I end up getting 10.52 A angle N equals 85.085. So now we can get an expression for A angle N, and that's just going to be 85.085 divided by 10.52. So I get 8.087. So then we can substitute the formula. 1 minus v to the n upon I equals 8.087. You could also use a financial calculator. Multiply both sides by I, which is given to us. So 1 minus v to the n equals 8.087 times 0.105. I feel like we've done the important part of the problem. 0.849. So we get v to the n is equal to 0.15. All right, almost there. Now, from this expression over here, we can figure out what v is, because it's just 1 upon 1 plus I. So we substitute in the calculator. 1 divided by 1.105, and we get 0.905 to the nth power equals 0.15. Let's take the natural log of both sides. And now we can take that n out as a property, right? So I get n, and then I'm going to divide both sides by ln 0.905. Let me show that step. So divide both sides by this. And finally, we have our answer. So ln 0.15 divided by, be careful with your parentheses, natural log of 0.905, and we get 19. Okay, so that's our answer.